Hi, we are Team D&E. My name is George Hammond. I was in charge of data management. These are my teammates.
I'm Justin D. I was in charge of web interface and the web server.
I'm Neil Mustafa. I was in charge of some networking and some programming.
I'm Eric Hill. I was in charge of RF communications and circuit design.
I'm Simon, and I was in charge of hardware and implementation.
Our design is a cloud-hosted intelligent sprinkler system. The problem we were trying to solve is that a basic in-home design sprinkler system is pretty simple in nature. It includes like a basic timer and then just runs when you tell it to based on the schedule you set. We wanted to kind of elaborate on that design a little bit, so we designed something that has a bit more features attached to it. To do this, we have a web-hosted interface, which a user can access on their own. The web interface provides controls such as manual override and schedule setting. It's an interface that can be accessed anywhere, and the user can change parameters as they please on the go. This website also works in conjunction with our wireless sensor nodes that we have that go in the environment, whatever the user is installing the sprinkler system on. In our case, we decided to use just a home, so the backyard and front yard. These wireless nodes get sensor data from the moisture sensors and help us diagnose information about the environment. And all this is connected to a hub that we have installed, which is a one-to-one replacement of whatever sprinkler system was there. It's directly compatible. The hub also interacts with, weather APIs and the other components of the sprinkler system to bring everything together. So it takes information from the website, takes information from the wireless nodes, and then outputs our signal to the sprinklers telling it when to run. So the basic information and criteria we have for that is current weather, the future weather, so if it's going to rain, we will avoid running the sprinklers then. We have the schedule parameters, and we have the moisture data. So if it's too wet outside, we also don't want to run the sprinkler. That's the basic design, and hopefully with this, we aim to reduce the amount of water and consumption from a regular sprinkler system by watering only when it's necessary.
So how do you get external weather data from the weather reports, or you do just your own analysis?
We have both. So for current and future weather, we just use Open Weather Map API to source that data. And for environmental data like moisture in the ground, we have our sensors.
Yeah.
Hey, George, I saw you guys back in last semester. So I'm hearing the same information that I did. Did you actually, it says goals, did you actually achieve it? And did
Yes,
you
the whole design
physically
is-
structure it? Is it something that is basically functional
It's
that you
implemented
guys
in my
could?
house.
Okay, all
Yeah,
right.
design is-
It would be good if you actually said that, on your slide, because, I'm literally hearing the same pitch. So, you're trying to tell us is something that you've achieved. I haven't heard that much difference in your pitch from
Where did you
December
put
class.
that?
Implementation
Where'd you
is
put the sprinkler
important.
system?
It's in my home, and we're streaming it.
Okay.
So you don't include any results on the slides. Did you do formal testing and achieve a performance metric?
Yes.
Yes, this past week we did like a full runtime, full real-time usage of the system.
So that's a good thing to mention.
Yes, very good thing.
Slide.
Can you talk about the solar system? Is your sensors assuming only solar system, or can you use any source?
No, it could use lithium-ion battery too, but the lithium-ion battery alone is good enough to last 4 years.
Okay, but the original input is using your wireless, your home wireless system or not?
That's only to control whether the sprinklers turn on or off. There's two 1310s which are talking to each other. A transmitter, which is attached to the sensor, that's all wireless, powered by a lithium-ion battery. So that's no external power, just a lithium-ion battery and solar panel. And then there's one in the garage that's kind of like the motherboard of the system that's actually going to be receiving a signal and determining whether to let current flow and turn on the solenoid.
How big is that physically?
Say like about.
The battery. You say it's a 4-year battery.
Oh, it's
but-
like probably that big.
Okay,
It's
so
the size of
that.
a phone battery.
Yeah.
Okay, so you're
Probably the
proposing
size of
that
like an
your solution has a sensor out there that's the size of a cell phone.
Basically, yes.
Okay, so there was no physical constraints on how big the sensors could be or anything like that.
No, sir.
We'll have to stop there.
Okay, thank you very much.